Hello, and welcome back to Learning with Lee. In today's episode, we're going to take a look at templates. And what templates allow us to do is they allow us to convert our classes, such as link and linked list down here, so as that they happen to be a bit more flexible than they currently are. Because at present, our links and our linked lists only work for integers. They won't work for floats, they won't work for custom classes and objects that we might be creating in the future. So, the way in which we end up doing this is we use what are known as templates and use the keyword template as you might imagine. And then the other thing that you use, and you might have noticed this in some of the other stuff that I've done in terms of, I might have shown you vectors earlier on, but you use this less than followed by a greater than to form sort of this little diamond shape. And within there, you do something along the lines of class T. And what this allows you to signify is that this link is going to be customized whenever it's instantiated for a particular type of class. And you can also use things such as integers and floats in that, but for now, this is good enough for how we're doing this. And what we can then do is rather than having our link take in a value, it takes in a t value rather than an integer value. And we're going to have to update a lot of this in the future, but also things like getItem has to return a t and it returns item. Item now needs to be of type T. And this is all stuff that will get handled on compilation so as that it can be customized relatively easily. Anywhere else in here that we need to really adjust for it? Not at present. So right now, what we need to do is we need to go on over to link and make the appropriate changes to it. Fortunately, there weren't too many things we actually had to change within the definition of link, because the way in which this is done for C++ is a bit uglier than it's done in certain other languages. And that primarily has to deal with the fact that, well, actually, yeah, we're going to have to deal with this for quite a few items in here. And that's because we have to specify before every single one of these methods in here that it is a template of class T, as well as then over in here, we have to, I believe, do link sub t in order to properly set this as it is. Oh yes, and over here, do t value. And then that'll fix that. Then if you note down here, once again, have to do this, and that fixes all the bugs in there. And unfortunately, we have to do this for every single item in here. So that's going to be a bit of an annoyance. And I'll just cut when I'm done with having put all of these in. Welcome back. So, I've updated each of our definitions that we have within this class link to now have template class T here, as well as also to be in the link and then T namespace. And finally, the other change I had to do was I had to get rid of, in case you notice up here, my link pointer. And that's because it does not have the ability to really end up having a type def that also covers templating. And as such, what I had to do in here was just replace those instances in which I happen to be using link pointer with link and then the type T in here, followed by the fact that it's a pointer. And pretty much had to do that throughout here. As you'll notice, there still are a couple errors, and that's because we have yet to update linked list. And same thing for over here, because right now it still is using link pointers. And, however, here's the problem. What I could do is I could do something such as, okay, I want a link of int, and I'm going to specify that that's what I want pop to return. The problem is that in case link, or more accurately, all the links in this list, in case they aren't all of type integer, we're going to have some problems then. So what we need to now do is we need to apply a template to linked list, so is that it also happens to end up using the same sort of logic that link is, and that it can be used for pretty much any type that we feel like giving it. Now it's going to have some potential problems, in that not all types that we give it are going to have things such as less than or greater than defined for it, so this comparison operation may not necessarily succeed, even though we have these operators up here defined. Their end result might not be accurate, and we'll get into what ends up happening then in a couple of episodes. So for now, well, all that we really need to do here is pretty much the exact same thing we did before. We add in our template before linked list, which signifies that anywhere that's going to be using that linked list needs to supply some form of type. Then down in here, we need to replace these with link pointers like this, so as that they end up actually having the correct item. Then we're also going to need to get rid of list pointer again, because now that it's templated, it has the same problem that this one up here can't have a template with it. Because even if we try to do something like template class T here, do this, it's going to give us this syntax error. For that, you can try to put that before the type def. Once again, that's going to end up on build giving us an error. In that, you can see here, has a type def template is illegal. Even if I try to do something such as that, still going to complain about it. So you can see how that's going to end up giving us a bunch of issues. So I need to get rid of that. Before every one of these, I need to start adding in our template class T's. And then I need to go back through, update all of the link pointers in here to link sub T pointers, and same thing for our list pointers that we previously had. So once again, I'm going to cut, and I'll rejoin you once I'm done. Once again, welcome back. As you can see over in here, as well as over down in here, we now have our linked list T's, similar to how we have our link T's. And we have our template class T's and linked list namespace sub T's all throughout here. And now that we have that all done, that leaves us with two additional major problems we need to take care of. The first of which is our sorting, because this all needs to be templated so that we can actually use it for all the different types. Then we also need to template out our interface so that our interface can be useful for this entire general process here. Unfortunately, well, there's going to be a bit of some problems once we get to generate random list, that this isn't necessarily going to be that easy to deal with in terms of solving it to be not just an integer, but we'll deal with that in a little bit. So for now, let's start off with our merging and the different algorithms here and the changes that need to be made. So to begin with, we just need to, first off, paste in our linked list sub T's throughout here, as well as we also need to template those, because even though they aren't in a templated class, in order to have a templated class in there, they need to be templated functions, so it needs to know what T is. So we need to tell it that it's a class. And there's different ways in which we can, in the future, cover the types of things that T can be, such as one of the common examples happens to be, in case you want to have something have a specific size for it, or something along those lines. And we'll deal with that in a little bit. But for now, we make those changes. Then down in here, once again, have to do this. Fortunately, we don't need to go with, because of the fact that they aren't in a class, we don't need to also add in this sub T. Now we just need to go through and modify our pointers to linked lists and the like, so as that they actually are a bit more intelligently named, since we unfortunately can't type def them. Let's just get that correct. And then we also need this down here, which is not a pointer, but just that. Then we have our links, and that's really all that we need to change. So let's grab a link T pointer and replace these three here. So as you can see, it's a relatively quick set of changes. We can build this just to make certain that there aren't any errors in this file or in this header file. And now there aren't, which leaves us with the one major spot where our errors are, which is here. To begin with, we're not really going to be able to get back this particular type of an item to begin with, which either would mean we would have to expose what happens to be a linked list, or we're going to have to come up with something a bit more creative in order to hide that. So the first thing we can do is within here, we can create basically a interface class. So let's just go with and for stars, we're going to, well, we can name it iLinkedList within here. Or if we want to, we can also then, to sort of maintain our general naming conventions, rename this one here to ILL. Then within here, let's have ourselves a class iLinkedList. And what's important is that similar to, if we head on over to our header file in here, it's going to be a templated class. And that's because it's going to act as an interface to sort of hide the fact that we are actually doing these other things involving linked lists and pointers to those. So this is going to be what's known as a wrapper class. And by that, I mean it's something similar to wrapping a sandwich in either some paper or something like that. So for now, it's going to be used in order to surround and hide and obfuscate the implementation of the linked list behind it. So what we're going to do for it is we're going to get rid of this typedef. We're going to have that. We're going to add in its appropriate scope around it. And now within here, we're going to need to make a few minor changes for this. So rather than a list pointer, this is going to need to be a ll linked list sub t, or actually alternatively, what we can do for this happens to be, since we're dealing with a class here, let's actually just go with a item to actually delete this class. Oh yeah, we need to make some of this public, and then we're going to want some private information. Let's make our linked list private. So we're going to have a linked list sub t, and we can just call it our list. And we might, as a result of this, end up changing how we do generate random list, because that's probably going to be something that we do as part of the constructor here. So let's just say that we have I linked list sub t, and we want it to take in, once again, similar to a generate random list, some number of elements to specify how many we're going to have. We're going to have to do a bit more work in order to determine exactly how we want to actually generate this random list so as it generates a random type, well, generates them appropriate for the type. However, for the time being, that's probably good enough. Then over here, we can have our destructor, and for this, we're going to just go with I linked list. It's not going to actually bother creating it for us, so we can just go with this. And all that this is going to do for us is it's just going to end up calling through here for delete list, in which it's going to not take in any arguments, since now we actually have this as a part of this class, and we're just going to delete that list. Then, and once again, the important thing to remember is that delete is what we use for classes, free is what we happen to use for dynamically allocated memory. Then down here, generate random list, we don't actually need this. So what we can actually do is we can do in here, we can just do list is equal to, and let's just grab this guy, move him up here, and that's all that we need to do for that. Get rid of this guy, and we're done with those. So then also we need to be able to output this thing. Same thing as we did there, so let's just grab then also similar to how we have this OStream operator here. We can just grab this portion of it, add it into here. Once again, we can just make this a, well, we could make it a friend. Alternatively, we can just do this so as it just takes in the OStream. And then what we're going to do is we're going to go, and this is relatively simple because the final thing we're going to do is we're going to return the stream. But before that, what we're going to do is we're just going to go and pipe on out our list. And that's really all that we need to do for our output, so we can get rid of this section here. And then we have merge sort. So we can just go with, we have this already. We don't need to take in a list since this is containing that list. So let's just go with avoid merge sort. That takes in a, well, nothing really. Then it's going to use that linked list sort, and that's going to merge sort list. And unfortunately, let's see right now. Oh yes, and we have to do merge sort sub t. So now that we've finished up with our interface, as well as also our classes for the linked and the link, well, the link and the linked list, as well as also then the merging, all we have left now is to make our changes to intro. So for starters, we change our namespace for our interface since we changed it in here. And then down here, we make this using an I-linked list. And for now, we can just go with int. And we don't even need generate random list to be called, we just call it constructor. And from now on, we're using list here. And for starters, we don't need to check if it's a null pointer because it's not going to really be ever null. So what we end up then wanting to do is we want to do this .merge sort, and we're not really taking in a list, so we can just do that. Then we have our little clock going here for that. Oh yes, we can remove this one here so as it doesn't cause us any errors. Then over here we just need to use cout, output our list, and then we're done with that. And then our list will get deleted as soon as we exit our context down here for exiting the scope. My apologies for the rather abrupt cut. Unfortunately, fixing one bug led to me fixing a few other bugs, which led to one rather interesting problem that I figured I'd want to cover in another episode, just due to how nuanced and how important of an understanding that this comes from. And that has to deal with these link errors down here. And we haven't covered what the linker is or what it's used for. So in the next episode, we're going to take a look at the linker, as well as why templates have some weird oddities about them in which basically they have to be included the same way you would a header file. So we're going to get into that in the next one. Thank you very much for watching today's episode. I hope you have a wonderful day.